Hello, Math Study students, and welcome to your second lesson on statistics. Today we're going to be talking about simple discrete data and how we can arrange those via frequency tables and column graphs, also known as bar graphs. We will know we are successful when we can interpret and organize discrete data using various methods. We'll begin with a few terms of notation. Specifically, quantitative discrete data can be organized the following ways. We can use tally or frequency table and a column graph, also known as a bar graph. Now, these aren't the only ways that you can organize discrete data. You may have done things like stem and leaf plots in the past, or dot plots, frequency polygons, things like that. But the two that we'll be really focusing on are these column graphs or bar graphs, and then creating frequency tables. Frequency is a word that we discussed all the way back in probability on one of our first lessons, and it basically means the amount of something. So we're going to talk about amounts on a table. And then the column graphs we should be familiar with from previous classes, again, often called bar graphs. And again, this is for discrete data, quantitative, so we're talking about numerical data here, and it's counted data when it's discrete, as opposed to measured, which involves ranges or groups. And we will get to that on a different lesson. A few more terms of notation for us. Sometimes we talk about something called the distribution of data. When you hear about the distribution talks about where things are located, how they are distributed. And skew, which is a word we've probably heard before, but perhaps incorrectly, describes the distribution of the data. And here is what skew means. And most students come into my class knowing it backwards. Skew means stretch. So if you take a curve that is what we call normally distributed, this would be normal. Sort of like if we think about grades. You might have a few students up at the top end of things, getting the A's and the B's. You might have a few students not doing the work and failing or getting some low grades. But when you talk about sort of normal data, we have most things happening right there in the middle. And so most of our data is located in the middle or the mean or something like that, or the median, and that's what we refer to as normal data. You might have seen this as a bell curve, again, because most of the data is right there in the middle. Heights are another thing that would be like normally distributed. You have a few people that are very tall at the top end, a few people that are very small, but most people reside somewhere in the middle, and we've shown that frequency or that amount by raising that curve up on the y-axis. Now, if we get to the second one here, again, I said skew means stretch. So on this second graph here, if we took our original bell curve, which one of its sides have we stretched to make it long? And you can see that the arrow is drawn here to show that our normal bell curve might have been something like that. But this one side has sort of been stretched out, so it goes all the way there to the end. And so is that stretching into the left, or is it stretching to the right? Think about positive and negative numbers on the number line. If we go to the left, we're talking negative. If we go to the right, this is negative skew, negative distribution. Now you might say, but isn't all the data over there on the right? It is all on the right, which would lead you to say positive unless you know what skew means, which again means stretch. And we are stretching that curve out to the left. The last one here, again, if we had a normal sort of bell curve, it would go up and down and be symmetrical like that. But one side has been made longer, like the old Tom and Jerry cartoon where the cat or the mouse stretches the cat's whisker. That's what we're talking about, stretching it out. And so this is stretching to the right. And so this is positive skew or a positive distribution. Outliers, we've heard that term as well, and that one probably fits more within your normal definition. We may, at a certain point, talk about specific ways we can identify outliers, but in general, outliers are data that are much higher or lower than most of the other data. It's usually not even connected. It's away from the group. Relative frequency was something we covered when we discussed probability. We're talking about the thing we want over the total, or the thing that we're talking about divided by the total, which makes a percentage or a decimal or a probability. And mode, data that occurs most often. You can use that as an adverb or an adjective as well. Modal, like the modal group, is the group that appears most often. So any root with mode means most often. And, oh, and I've got that right here. Moving on. So on the previous slide, we talked about different ways to organize data, and I am showing one of those examples right now. What I've got here for you is a frequency table. You've got your data, or we can actually start with our variable. The variable we have here, we talked about last class, the variable is like a label. And for this data, the label is the number of cars. Now maybe it should be more specific, number of cars in a certain parking lot, or number of cars owned by people, which is the data that I think this is. And so how many cars do the people own? And some people selected 0 or 1 or 2, so on and so forth, all the way up to 5. And now that doesn't mean that if one person doesn't own any cars that nobody else can, but in this particular case there was only one person. The frequency was 1 for owning 0 cars. So one person owned 0 cars. 5 people here owned 1 car. So again, the data is 1, but how often did it occur? 5 times. It's like me going around and saying, when was your birthday? That would be a categorical variable, but I could go around and someone might say February, and somebody else might say April, and then somebody else says February. Oh, well now it's still the same data, but it's occurred twice, and so that would have a frequency of 2. Well, again, here we have the data of 2 occurring 10 times, so on and so forth. Now, if we wanted to figure out how many people were interviewed for this question to figure out this data, the first thing we could do is actually add up the frequency, much like we did for probability. So if we add up this column, we have 1 plus 5, which is 6, plus 10, 16, plus 9 more is 25, and the 4 and the 1 bring us up to 30. So a total of 30 people asked here. The answers were 0 through 5, but as we see, there were multiple people who answered for questions 1 through 4, or the number 1 through 4. What we want to do here now is organize this discrete data into a column graph or a bar graph. First thing we want to do is we want to put down our X and Y axes. And we have to remember it's discrete data, it's not continuous. So our columns or bars will not touch each other. They will be disconnected, which is a sign of discrete data. And so we can see that our data is only going up to the value of 5, but what we're really measuring is the frequency of the data on our Y value. So I'm going to put frequency right here for my Y axis, and that goes all the way up to 10. So I'll probably go by 2 since I don't have a lot of room here. So 2, 4, 6, 8, 10. Can put a scale on there, which is always good to do. And then I can label my my X-axis, which is going to be my actual data, the number of cars. So label that. There's my variable, number of cars. Again, the Y-axis is my frequency. It's not actual data. It's just counting up how often the number of cars occurred. And then we can put our different values. Here we're not going to use it like a number line starting right at 0 at the origin. We're going to plot each discrete value separately. So we have 0, we have the 1, 2, 3, 4, and 5. Because each one of those will have their own separate column. And again, they'll be disconnected. So for 0, we see we go up to 1. And so that's just going to go up to halfway between the 0 and the 2. For 1, our frequency is 5. So there were 5 people that owned 1 car. And that should go up somewhere here. Again, trying to line that up about halfway between. May have been a little off. Maybe I should go a little higher. And then we've got 10 people with 2 cars, and that was right here at the top of my scale. And then so on and so forth. For 3, we had 9, so just a smidge below the 10 here. And for 4, we had 4, which should be right around here. And then people owning 5 cars, again, we go back down to just 1. And that, ladies and gentlemen, is a column graph, again, often referred to us as a bar graph, but IB will always call it a column graph. Again, it allows us to look at our data. We can see all the different data values, 0 through 5, and then we can see how often they occurred by looking at the Y-axis of the frequency. For homework, we're going to look at page 164, numbers 1 through 4, and they will focus on these vocabulary terms that we just put up, as well as frequency tables and column graphs. We will see you next time.